So take a look at this integral. The only way we have that we could evaluate this based on what we know so far is by multiplying it out. 2x plus 1 times itself 6 times. That gives us a polynomial, and we know how to integrate polynomials. Okay, well, that's a lot of work, right? And I'd really like to not have to do that much work. So it turns out there's a better way, right? Here's what I'm going to do. I'm going to make a substitution. I'm going to let u equal 2x plus 1, right? That thing that's inside the parentheses. Because here's my thinking. I know how to integrate a variable to the 6th power. It's the 2x plus 1 that's getting in my way. If I can eliminate that, then I'd be in good shape, right? So here's what's going to happen when I make that substitution. This is going to become the integral of u to the 6th dx. Okay, that's progress, but I still have a problem. I'm integrating with respect to x here, which doesn't match my variable. Right, but I can fix this. Go back to the substitution. If I differentiate that, it becomes du dx equals 2. Now here's what I'm going to do. I'm going to treat that du dx as if it was an actual literal fraction and multiply both sides by dx. Now, that's a little sketchy, if I'm being honest with you. All right, but in this case, it actually works out really well for us. Right, so if I do that, essentially I'm going to solve for dx. Dx equals du divided by 2. Now I'm going to substitute that into my integral. And it becomes the integral of u to the 6th times du over 2. And this I know what to do with. First I'm going to take that 1/2, bring it out in front. So this is 1/2 the integral of u to the 6th du. And that integral I can do with my power rule for integrals. That becomes u to the 7th over 7. Plus a constant, and I still have that 1/2 out in front. Now, I'm not quite there yet, because I want my answer to have the same variable as the original expression, as the original integral did. So I have to go back to x's. But that's easy to do. I'm just going to use my substitution again. I'm going to substitute the other way. I'm going to replace that u with 2x plus 1, and this becomes 1/14 times 2x plus 1 to the 7th, plus a constant, and that's it. Right, there's my answer. Okay, so how about this one? It's similar, right? I'm looking at this and I'm saying if that 4x squared minus 7 were just an x to the 7th I could integrate, not a problem. Right, so here's my substitution. I'm going to let u equal 4x squared minus 7. If I make that substitution, the integral becomes the integral x u to the 7th dx. So now I have an even bigger problem. Not only do I have that dx, but I have that x floating in there as well. But watch, that's going to get handled exactly the same way. If I differentiate this thing, it becomes du equals 8x dx. I went ahead and moved the dx to the other side. That's how these usually get written. And now I'm going to solve this for dx. Dx is du divided by 8x. I'm going to make that substitution into my integral. And it becomes the integral x u to the 7th du over 8x. You see why I wasn't concerned about those x's now. Right, the x's are going to cancel. I'm going to bring the 1/8 out in front like I did before with the 1/2. And this is an integral I can do something with. The integral of u to the 7th du is u to the 8th over 8 plus a constant, and we still have that 1/8 out in front. And now I'm going to do the same thing. 8 times 8, that becomes 1/64. I'm going to put 4x squared minus 7 back in there for u, and I get my final answer. 1/64, 4x squared minus 7 to the 8th, plus a constant. Okay, so let's talk about the thought process behind choosing to use this method. What I'm looking for is a part of the integrand where if I remove it and replace it with a single variable, it becomes something that I can integrate. Right? U to the 7th I could do. And I want the part that's left over, the x in this case, to be equal to the derivative of that thing, give or take a constant multiple. I've got an x left over here. The derivative of 4x squared was 8x. The 8 didn't bother me, right? Because the 8 just kind of became a constant that got substituted in, and that was fine. Right, so that's what we're looking at, kind of as a big indicator that this is going to be a good method to use. Now, there are other circumstances where you can use it, and that's what we're going to look at in the next lecture here. We're going to look at a couple of examples that apply this substitution method to some more unusual cases, right, than the ones we've seen here so far.